Alright, good morning guys. Mr. Middleton here. Today we're talking about the angle addition postulate. After this video, I would hope that you would be able to use the angle addition postulate to find the missing angle measures. Okay, let's jump into it. An angle, okay, usually written like this, referred to like this, okay, like a less than sign except flat on the bottom, is formed by two rays with the same endpoint. And the endpoint is called the vertex. Alright, so looking at this example here, name the rays that form the angle. Well, we have this ray, ray BT, and this ray from B to Q, ray BQ. Alright, and the vertex, that endpoint, is B. Alright, so there's a few ways that we can name these angles, and so let's go through it. We could call this angle angle 1, okay, because the 1 in here indicates that they're referring to that angle. If we have a bunch of angles, you might see that in the problem to make it easier to talk about it or refer to it. We can call it angle B, because that's the vertex of the angle. There are some situations where we won't want to call it angle B because it might be confusing. We'll look at that a little bit later. And we can name it in the same way that we would draw it without picking up our pencil. So if we're going to draw this angle without picking up our pencil, we go from T to B to Q. Okay, and so we can call this angle TBQ. Or we could go from Q to B to T. And so we could call this angle QBT. Okay, notice that when you're naming the angles, the vertex, this B, angle B, is always in the middle. Okay, it will always be in the middle. Again, unless we're referring to it as a numbered angle. Alright, so looking down here, if you feel like you got this and that makes sense to you, try to name these angles in another way. Number 1, angle 1, we can call that angle ABC. You can also call it angle CBA. Number 2, we can call that angle CBD. Again, we could call it angle DBC. And this says name angle B in another way. Now this is tricky, okay? And this is the reason we do not name angles this way. Because when they say name angle B another way, we know that we can name an angle by just its vertex. We should never say it this way in this situation, because angle B could be referring to 3 different angles. We could be talking about CBD, because this is the angle there, there's a vertex there. We could be talking about angle CBA, okay, again, that's the vertex there. And we could be talking about angle ABC, or sorry, ABD, it's the vertex there. So there's a bunch of different ways that we can do it, and this is why we would not refer to it as angle B. There's too many things that we could do. Okay, so it could be talking about angle 1. It could be talking about angle 2. It could be talking about angle ABD. Okay, and this is why we don't name it just the vertex when we're looking at a bunch of different possibilities. Right? It's like screaming out a last name at a family reunion. Okay, you'll get everybody to turn around. Nobody knows what you're talking about here. Okay, last one. How many angles are in the figure? We got 1, ABC, 2, CBD, and we actually have 3, ABD. We have 3 angles here. Okay. Okay, classifying angles. This should be a review for you guys. An acute angle has the following measures. Acute, for us, should mean that it is greater than 0 and less than 90 degrees. A right angle means the angle measure would be equal to 90 degrees. An obtuse angle would be greater than 90 but less than 180, and a straight angle is 180 degrees. So acute, small, Sorry, make sure I keep this a little bit more straight for you guys. An acute maybe looks like this. Okay. A right angle you guys should be pretty familiar with. Okay, and a lot of times to signify that it's a right angle, you'll see a box in the corner. An obtuse angle look more like this, bigger than 90, and a straight angle is just a straight line. Okay, and you can basically refer to everything by the straight line and the 90-degree angle. Okay, if it's smaller than 90, it's acute. If it's bigger than 90 and not a straight line, it's obtuse. And if it's a straight line, then it's a straight angle. All right, flip it to the back. All right, so let's talk more about let's start talking about the angle addition postulate. The angle addition postulate says if B is interior of angle AOC, so B is on the interior of angle AOC, just like it is here, then angle AOB plus angle BOC equals angle AOC. And what that just means, again, part plus part equals whole. We take AOB, this part of it, we add BOC, this part of it, and we put it together, it means it equals the whole thing. So this is very similar to the segment addition postulate. Difference is we're talking about angle addition. Okay. Scenario 2 says if angle AOC is a straight angle, then angle AOB plus angle BOC equals, we can say angle AOC, we also say 180 degrees. Now this is really the same exact thing. The reason for these two different scenarios and really different parts of the postulate is that in scenario 1 we talk about interior of angle AOC. If it's a straight line, there's no inside of the angle. So that's just setting up that different situation to make sure we cover all of our bases. We kind of talked about the peculiarities of math when we were talking about definitions and how specific they have to be. Okay, so this is just us being really specific. It's the same thing as scenario 1. Okay, in both cases you can think part plus part equals whole, just like segment addition postulate. So use the figure below to answer the questions that follow. So it says find the measure of angle CBA. Now for this problem they told us that angle DBC was 24 degrees, and they told us that angle ABD was 83 degrees. And I'll usually do something so I can see. Alright, so CBA then, we should say, okay, well, part plus part equals whole. So I'm going to just say x for this thing. So I know that 24 plus x should equal the whole 83. So to find out what CBA is, I'm going to subtract 24 from both sides. That should give me 63, 59 degrees. Oops, let me write this. X is 59. Okay, and I know that x in this sets up for the measure of angle CBA. So I know that the measure of angle CBA is 59 degrees. I guess I could have just wrote 59 degrees there, but it all works out. 59 because it says measure, so I'll just write the number 59. Okay. Next example, we're trying to find x. They want us to write the equation and solve for x. So this next example, they told us that RQS is 5x minus 13. They told us that TQS was 3x plus 1. Now this problem can be kind of tricky if we don't know how to classify our angles, but we just talked about it, so we do. What kind of angle is this? Well, it's a straight line, so it's a straight angle. That means it equals 180 degrees. So I can say, well, these two parts, 5x minus 13, okay, adding that to the other part, 3x plus 1, should equal the whole thing, which I know is 180, AOC. And now I just saw 5x plus 3x is 8x, Negative 13 plus 1 is negative 12. So 8x 8x minus 12 equals 180. That means 8x will equal 192. That means x will equal 24. Okay. And then it says to classify each angle. So when it's asking us to classify each angle, it's really important for us to know what the measure of the angles are. By looks, we could classify these as acute or obtuse and acute, but I will caution you that with geometry problems that they're not always to scale. Okay, even without the notice that they aren't to scale, we should assume that we need to check our math before we submit our questions. So I'll plug this in. 24 times 5 is 120, minus 13 is 107. So this would be 107 degrees. That's obtuse. RQS is obtuse. Greater than 90, less than 180. SQT, there's two ways I could do this. I know the whole thing's 180, so I could do 180 minus 107. Or I could plug it in. I'll just plug it in. That's 60, 72. 72 plus 1, which is 73. So 73 is less than 90. It's acute. Okay, and I can double check. 107 plus 73 should give me 180, and it does. Alright, last problem. If you feel like you got it, go ahead and try it, and pause the video and try it on your own. If you don't, feel free to walk along with me. Alright, so for this last problem, they tell us that angle AOD is 107 degrees. AOD is this whole thing. AOD, whole thing. Going 107. Okay. They tell us that BOC is 3 more than double AOB. So BOC is 3 more than double AOB. Okay, so we're going to have to do a little bit of algebra really to make this work. I know that we're comparing everything to AOB. So I'm just going to call AOB X. They tell us that BOC is 3 more than double. So 3 more than double. That's 2x plus 3. Okay. Alright, sweet. I'm going to move this 107 out of the way because it confused me how it is. Okay. Okay. Alright. Now, for this problem, I hope you notice, really quick, that there's some markings down here by the vertex of these angles. Okay, there's an arch here and an arch here. These arcs tell us they're the same thing as our dashes for our segments. They tell us that these angle measures are the same. So they told us AOB, and this diagram tells us that COD and AOB are the same. And so we have it there. We know that COD is also X. And now we're going to use our angle addition postulate to figure this out, because I know that part plus part equals whole. So x plus 2x is 4x. 4x plus 3 equals 107. So 4x equals 104. Divide by 4. X equals 26. All right, 26. 26. Yes, all right. X equals 26. So now I can find BOC by plugging this in. 26 times 2 is 52. 52 plus 3 is 55. BOD, that's 55 plus 26, which would be 81. And AOC should also be the same. It should be 81 as well. Okay. Again, notice that the markings on the angles, those represent congruent angles. Congruent. Alright, so that's the angle addition postulate. Come ready to do some practice tomorrow. Alright, see ya.